Welcome to the DIY Honda Garage channel. This presentation covers the Diagnostic Trouble Code, DTC P0533, for AC pressure sensor circuit high voltage in the Honda Pilot models from 2016 to 2022. This DTC indicates an issue with the AC pressure sensor, which is crucial in regulating the air conditioning system's functionality. The AC pressure sensor is located in the AC system, and it monitors the refrigerant pressure to ensure optimal performance. When the sensor experiences high voltage conditions, it may indicate problems with the sensor itself or related circuit components. Understanding how to troubleshoot and resolve this error is vital for restoring the proper functionality of the vehicle's air conditioning system. The AC pressure sensor is responsible for monitoring the refrigerant pressure within the air conditioning system. It is critical for preventing issues like excessive pressure, which can lead to system failures or poor cooling performance. This sensor is usually located on the AC accumulator or the compressor itself. By sending voltage signals to the Powertrain Control Module, PCM, it ensures the system functions efficiently. When there's a high voltage condition, as indicated by DTC P0533, it may prevent the AC system from operating correctly, thereby affecting the comfort and usability of the vehicle's climate control. Identifying the problem with this component is essential to ensure the air conditioning works effectively. There are several possible causes for DTC P0533. First and foremost, a faulty AC pressure sensor itself can generate a high voltage reading, leading to this trouble code. It is also crucial to consider electrical issues such as loose connections or poor contact points within the AC pressure sensor circuit, which could erroneously send high voltage signals. Additionally, damaged or frayed wiring between the sensor and the PCM can disrupt normal signal transmission, resulting in inaccurate voltage readings. Awareness of these possible causes helps target areas for inspection while diagnosing the code, thus streamlining the repair process. When dealing with DTC P0533, you may observe several troubling symptoms in the vehicle. One of the primary signs is poor AC performance, where the system fails to cool the cabin effectively. Additionally, you may notice unexpected shutdowns of the AC system when the vehicle is operating, which can be particularly frustrating during warm weather. This issue might also lead to increased engine load, potentially affecting overall vehicle performance. Recognizing these symptoms aids significantly in diagnosing the root causes of the problems faced while using the air conditioning system, ultimately leading to a resolution of the DTC. The first troubleshooting step for DTC P0533 is to verify the problem thoroughly. Start the engine and let it idle, turning on the blower switch followed by the AC switch. It is critical to monitor specific parameters using the Honda Diagnostic System, HDS. At this point, check the AC pressure sensor's signal voltage. If the voltage reads above 4.75 volts, it confirms the failure, and you should proceed to step 2. Conversely, if the readings do not meet the threshold, the issue might be intermittent. In such a case, investigating poor connections or loose terminals at either the AC pressure sensor or the PCM will be necessary. Observing the board snapshot and attempting to reproduce the failure in identical conditions will enhance the accuracy of your assessment. To move forward in the troubleshooting process, turn the vehicle to the off, lock mode, and disconnect the AC pressure sensor's 3P connector. If you use a jumper wire to connect terminals A and B on the AC pressure sensor connector, you can proceed to turn the vehicle to the on mode. This step allows for another check using HDS. Assess the voltage from the AC pressure sensor. If the value exceeds 4.75 volts, proceed to step 3 for further diagnosis. However, If it does not meet that threshold, replacing the AC pressure sensor is necessary, as it indicates a faulty component. This replacement is crucial to restore accurate measurements and optimal AC functionality. In this step, you will again turn the vehicle to off lock mode and remove the jumper wire that was connected previously. Next, power the vehicle to the on mode while keeping the AC pressure sensor 3P connector disconnected. Your task now is to measure the voltage between two designated test points on the sensor connector. Specifically, test points 1 and 2. This test aims to ensure you have a readings close to 5.0 volts. If you achieve this desired voltage, it indicates that the wiring is in good condition, so you can proceed to step 4. If the readings stray from this point, you should proceed to step 5 for further diagnostics and evaluation of possible circuit issues. In this step, turn the vehicle to off lock mode once again and ensure the SCS service check signal line is jumped using the HDS. Disconnect the PCM connector E, which has 80 pins. You need to check for continuity between 2 points. Test point 1 on the AC pressure sensor connector and test point 2 on the PCM connector, specifically pin number 35. Conduct this test with the vehicle in the off lock mode and the AC sensor connector disconnected. If there's continuity between the 2 points, the AC PD sensor wire is functional. If trouble codes persist, refer to authorized service information or consider substituting a known good PCM for further testing. Otherwise, if continuity is absent, it's essential to repair any open circuit in the wiring linked to the AC sensor. The final troubleshooting step involves again turning the vehicle to the off lock mode, while also jumping the SCS line with the HDS. Disconnect the PCM connector E 80P to proceed with your checks. Like in previous steps, you will want to check continuity between the AC pressure sensor 3P connector and the PCM connector, but this time between pin 1 and pin 58. Conduct this test with everything safely disconnected and the vehicle off lock. Achieving continuity here confirms that the SG2/SG6 wire is working effectively. If there is continuity, review authorized service information or substitute unknown good PCM. However, if no continuity exists, repairs should focus on any open circuit found within this wire between the AC pressure sensor and PCM. To verify the repairs made for DTC P0533, the first step is to recheck the entire AC system to ensure all replaced components function correctly. Clear any diagnostic trouble codes, DTCs, from the PCM using the HDS. Following this, conduct a test drive to see if the air conditioning operates without issues during normal vehicle use. Observing the AC performance during this test drive helps determine whether all repairs were successful and if the code reappears. This comprehensive verification process guarantees that the vehicle meets its necessary operational standards and ensures driver comfort. Preventive maintenance plays a critical role in ensuring the longevity and functionality of the AC system in the Honda Pilot. Regularly inspecting the air conditioning system can help identify signs of wear or potential failures before they escalate into serious issues. Additionally, routinely checking connections and wiring for any signs of loosening or corrosion is essential for maintaining proper electrical flow and signal integrity. It's also vital to monitor refrigerant levels frequently, as low refrigerant can strain the system and lead to sensor errors like DTC P0533. Following these preventive measures can significantly enhance the reliability of the AC system and prevent unnecessary downtime. In conclusion, understanding the causes of DTC P0533 is important for efficient troubleshooting and repairs. The detailed, step-by-step approach outlined ensures that technicians can follow a logical pathway to diagnose and resolve the high-voltage issue with the AC pressure sensor. From verifying the problem to conducting the necessary wiring checks and continuity tests, each step offers precise insights into component functionality. Regular maintenance of the AC system is equally vital in preventing future occurrences of this trouble code, ensuring that the system remains reliable and effective. Ultimately, by following these guidelines, Honda Pilot owners can enjoy a consistent and comfortable driving experience. Please like and subscribe to the channel. See you next time.